can do question answers. Thank you.
Mm-hmm. Yeah, I think it has been recorded. Okay, good. All right, so yeah, like I said, blockchain is really not a solution to a problem which is new to us, but it is part of the history of of early humans have been trying to solve um, a common issue that we still face every day. And let me explain a little bit on that. What is that problem, or what is the thing that what blockchain kind of brought up on a higher level. Um, so the concept of value exchange, like I said, early humans, when we were cavemen, and when we were not really having any kind of resources, and in the very early stages of human history, we were still exchanging value. We were still, for basic necessities like eating or farming or catching an animal, hunting or whatever, right? Hunter gatherers. We were still having this concept of value exchange because you could only do certain things by yourself. You actually need help to achieve a few tasks. So this would result in violence, and this would result in disputes and problems. So the whole concept of value exchange has been part of the human history since the early times. So slowly and surely we started using institutions to help us lower the uncertainty of having this value exchange, right? Institutions like banks, institutions like governments who are a governing body, who are acting as a governing body between two parties to be able to solve this value exchange. Like when we cross the border across from Windsor, do you choose to pay everything in US dollars, or that's how the governing body wants you to do it? Correct. So governing bodies have been introduced as a part of our value exchange system that the humans basically operate on a day-to-day basis. So if we talk about value exchange now, it basically comes into a small little window of economics. Like value exchange, quickly people think about money. There's a lot more in depth of value exchanges happening, but simple thing anybody could think about is money. So in 2008 the economy crashed, right? And in the same year, Bitcoin was actually introduced to the world. It was brought up to the world. Now Bitcoin, to be honest, to give my fair opinion, Bitcoin is something that does not excite me as much, but something that is working with Bitcoin, or which Bitcoin is working on it, is the technology that has the power, and it is going to impact the next few decades of the human history. It's the underlying technology of Bitcoin, which is called the blockchain. Now, blockchain is not the most sonorous word in the world, but blockchain is the technology that is going to help us unravel the complex problems that we do face, but we never really paid attention to it a lot. So, like I said, it's the underlying technology called Bitcoin, and the level of this technology is kind of talked about like it's like the internet. So if we think about the internet, in 1990, or before, even actually before that, when the internet was first introduced, it was just between three computers, talking to each other. But when it slowly and surely started getting adopted by people outside organizations, and publicly open internet started to exist, the conception and the mindset and the view of internet was very bad in the beginning. People did not like it. Like I specifically remember, we had internet cafes that you would go to, and you would access the internet from there. And I remember being a kid, and I used to be a little scared to ask my mom for money to go to the internet cafe. So every time I used to ask, hey, can I have some money to go surf the internet? And out comes a shoe flying at me. She's like, you're not getting anything. Now the times have changed. Now my mom gets so frustrated if she does not have any internet at her place, right? So the times have changed, and internet is something that now we cannot live with, right? Sorry, we cannot live without, right? So think about it as the same as internet. Blockchain technology came into existence in 2008, and slowly, because it's becoming an answer to a key problem that everybody's facing. It is getting adopted every day. Can somebody mute, please? I can still hear you. So now, when I said let's compare it to the internet, right? So if we think about the internet, here's the problem that I suggested in the beginning, called the uncertainty of value exchange. So when I send you guys an email, or when you send somebody an email, right? So essentially, you're sending them a copy of whatever that information is. Now that's okay when it's just information that is okay to share. But when it comes to money or intellectual property, or sending some kind of a patent that you don't want them to have access to, is a bad idea. So, like, if I'm sending you money, if I want to send you $500, it's really important that I still don't have them, and then you get it. So that's a problem that was found by cryptographers, and it's called a double spend problem. It is very important that if I'm sending you money, I lose it from my end, and then I send it to you and you get it. So you cannot have two existing copies of that money. In today's world, money is really easy to send, right? It's just a number that you see in your bank account through a phone, through a computer, or basically an app or whatever. You see a number in your bank account, and that's the money you have. So the easier it has gotten to send money, the bigger the problems have been coming into existence because of this ease of money spending, or money exchange, value exchange, right? So now, to be able to control this, again, what do we have right now? We have our banks, we have our governments that control and help us keep the records, right? Keep the records, establish the trust. So without having, so let's say when you're sending your employees the salary, you have to go through a payroll company that deposits the value exchange, the money that they deserve to be given for their time that they've given to the company. And we need to go through this middleman kind of scenario, so that it is helping us create our business, and continue with their life in a peaceful manner. So what is the problem, you may ask, right? Well, now the problem that essentially was not thought of as a problem, but it is all centralized. So if that centralized area, or the hub, or a server, or whatever it is, or if it's a one person who is responsible for doing the value exchange, if that person is for some reason out of the picture, or it's hacked, whatever, and so the centralized aspect of any kind of value exchange is a problem. Then let's say if it's about a specific bank. So if I'm getting employed by a new employer, and they have a account with an international bank. Now, if I don't have that bank's account, it's hard for them to pay me, because they have to go through multiple identities. And think about the millions of people who still don't have bank accounts. So they're completely out of the system. They are not part of the system. They're excluded from this world that is kind of operating based on banks and governments and institutions, right? So, and the third biggest problem that is that they take major pay cuts. I think, if I'm not wrong, the biggest money exchange that happens around the world is not because of Apple, it's not because of Amazon, that they're selling product, is because of people sending money between their family members. So remittance is the biggest value exchange that is happening, and the amount of pay cuts that is being taken from each money exchange happening, or each transaction happening, very significant. So here are the three big problems. There are multiple problems that we could sit and nitpick and bring up from this from this system that we have currently. But these were the three big problems that could be tackled with blockchain, right? So something that the analytical thinkers and our data analytics students would relate to is having a digital identity, right? We all have a digital identity of ourselves online. By that, what I mean is not social media profiles, but have you guys heard about cookies, right? When you use any kind of browser and they have cookies, what they're trying to do is they're trying to gather your information and understand your spending behavior. Anywhere you go on the internet, anywhere you travel on the internet and purchase something or just look at something, you leave your digital trail on those platforms. You leave some part of your thought process, your behavior on those channels, and it's accumulated and it's monetized, right? It's accumulated, it's monetized, but the biggest part of it, it's not controlled by you. You don't have any control over it because you have signed up for those kind of services. So Google, Amazon, Facebook, all these tech giants are collecting data about you that you have no authority on, right? It's about you, but you don't have any. So think about this. If I'm trying to buy something from Amazon, right? The only ethical thing that they would worry about is my bank account sending them a successful transaction to their bank account. In exchange, they send me what I purchased from their website to my location, right? That's all they need to know. Now, for location purposes, yes, they need to know my address. But do they need to know how many times I've looked up? I have looked up, a water bottle, and how many times I've tried to purchase the water bottle, but I've waited for a sale to come up. So all this data that had been generated by us on these various platforms are being utilized against, I wouldn't say against us, but like they're using that towards gaining more monetary power. And basically it's all against centralized, right? It's all against centralized. So the answer to all this is blockchain. Now you might think, so a few slides now I will talk about what exactly is the blockchain. So by definition, and I'm not going to read off a definition of something that is written on the internet, but I will try to explain it to our data analytics students as if they would understand it easily. So blockchain is a technology. It's a database, but it's a decentralized database. Okay, so it's not located on one central location. It's not on one cloud premise. It's not on one server in somebody's basement. It's a decentralized database that is like a public registry of assets and transactions across a peer-to-peer. So if I were to look at a blockchain, I will see all the transactions that are happening from a peer to peer, but their identity is not disclosed to me. Okay, but I know that the value exchange that was happening. So in this case, of course, Bitcoin is the easiest example. So the value exchange that is happening is authenticated by multiple nodes. So the way decentralization is achieved is that there is a copy of the blockchain on multiple nodes, as in multiple computers across the world. So there is a concept of mining. There are miners that are having like very, very fast computational power. And the easiest way to understand this is, our computers have i7 processors, right? Intel i7 quad 4 or sorry, quad 3.6 gigahertz processors or whatever your configuration is. But those are still not enough to do some complex math puzzling. Now, the reason I say complex math puzzling is because all this data that's being stored on the blockchain is cryptographically secured and it's locked to be able to keep the information secret and only be allowed to be decoded by the people who are supposed to decode it. So, for example, if I'm a miner and I have a copy of the blockchain, so I need that computational power and I need that power to be able to solve that math puzzle because It's a cryptographically encoded information. So because I have a copy of the blockchain, I can do the math problem solving, and if I get an answer, I have a copy of the blockchain. So the reason it's fascinating is because, okay, let's say I got a new block that came into the blockchain. Okay, so let's go through this. It'll be better explanatory. So a transaction happens, right? Let's say I sent Manjari 50 Bitcoins. I wish I could do that, but let's just pretend. So I send her 50 Bitcoins. Now that transaction is sent to global nodes, right? So it's sent on the blockchain itself. So when I send her that Bitcoin, each Bitcoin has its own unique code. So first of all, Bitcoin was not made out of thin air, right? It was given a unique identity. Okay, it was given a unique identity, and that identity cannot be duplicated and cannot be reused by any other Bitcoin. So if I'm sending her 50 Bitcoins, I'm sending her 50 unique coded information. Now, who is going to approve that I did not just, fake them or make them up on my own, and I'm just claiming to send her 50 Bitcoins? So there comes the miners, and they will be, because they have the original copy of the blockchain, they can confirm that, okay, this Bitcoin was originally made on the blockchain. It was mined by somebody, right? Now, mining is a different concept, but mining is extracting a Bitcoin from the blockchain, and transaction approval is a different concept. So let's just focus on transaction approvals. So when a transaction is approved by a miner, because he knows that, okay, I have this Bitcoin unique ID, and I know that this unique ID was actually on my wallet, because I received that block of Bitcoin, and I have that Bitcoin with me. Then I'm sending it to Manjari. So this transaction is approved because I have a valid copy of the Bitcoin that's being sent from the main blockchain, and the address that he's sending was the same address that he got to receive the receive the Bitcoin in the first place, and so on and so forth. So every network, every blockchain network has transaction approval rates. So it would be like, okay, if you initiate a transaction on a blockchain, people need to wait at least, let's say, 15 miners to approve it. So 15 approvals before you get a successful transaction from peer to peer. Okay, so let's say that the transaction went ahead and it went to the global network, and people are approving my transaction by doing and solving the math puzzle. And every 10 minutes, all these transactions that are happening around the world are summed up and made into a block. Now, this block has information of the transactions. So whoever sent it to whoever, what did they send? Was there a special information attached with it? It could be. It's funny. When Elon Musk tweeted for the first time about Bitcoin, that tweet was actually stored on the Bitcoin blockchain as part of the transaction, and then sent to somebody. So now it is always going to be there for eternity on the blockchain itself, right? So on the block, in the 10 minutes, you have all the transactions that have happened, and they are summed up, and it is linked with the previous block's hash. So a hash is a cryptographic way of encoding. So if you see a hash, it is just basically jumbled up numbers. But if you solve that math puzzle with high power computational devices, like graphic processing units or whatever miners use as a processing power, so that block is then linked with the previous block on the blockchain. Okay, and this is how you have a chain of blocks which are always going to be there for eternity. Okay, once this block is put on the blockchain, it could never be changed. Okay, so think about, now we've already talked about centralization, right? So now it's all decentralized because it's not on one person's computer, on one person's phone. It's on multiple nodes around the world. Now let's talk about security. So just try to understand this. If I were to fake a block, okay, if I were to somehow figure out, okay, this was the code for the Bitcoin I have because I already have the Bitcoin. So if I were to try and fake the block and try and manipulate the blockchain, what I have to do is not just I have to change the block that I'm trying to manipulate right now, but all the previous blocks, because they're all linked together up until, so the whole history of economics on that blockchain, and not just do that on one computer, but on multiple nodes around the world at the same time. So it is very tough to do. It's not impossible, but it is very tough to do. And it's just not enough time for people to do this yet, so that you could manipulate a whole blockchain that has been existing for we don't know how many years, and try to change each block from the beginning of the blockchain's life up until the block they are working with to be able to forge the records. So it's very, very difficult to do that. Now, I said it's difficult but not impossible is because there is this concept of a 51% hack, and so when the internet came out, nothing was perfect, right? It was just a concept. Again, it was not widely adopted. It was just the technology. It was just a concept. Slowly and surely, we have VPNs now. We have secure networks. You could work remotely from anywhere in the world, right? So internet has helped us evolve into a very better world that we've been living right now. So in the same way, when blockchain and Bitcoin came out, all these things were not thought through because they probably didn't exist, because blockchain never existed, right? So if we have a quantum computer which has very, very high processing powers, right? A quantum computer is basically a computer that changes the state of its bit from between 0 and 1 according to what it's supposed to be, right? So quantum computing could have the processing power to be able to manipulate the whole blockchain, so solve all these math puzzles together, and be able to fake the whole blockchain, right? But again, this was in the beginning of the era of blockchain. Now there are some concept of blockchains that are already tackling this problem. So it's fascinating. So it's actually not just an economical evolution that that blockchain has brought to us. It's actually a big innovation in computer science. Blockchain has not been promising to just solve the money transaction problem around the world, but also it's just a new type of technology that has brought to us by a few individuals who remain unnamed up until today. Not sure if somebody will come ahead and say I was the one who introduced Bitcoin, because it's just a name. Nobody has claimed that it is me who introduced Bitcoin into the world. So the white paper was released under the name of Satoshi Nakamoto, but that identity is probably made up. It's a group of people. It's an individual. Nobody knows yet. Okay, but it is an evolutionary innovation that has come into computer science. So now comes the biggest question. Now comes, how could supply chain benefit from this, right? So think of the uncertainty that I talked about in the beginning. Now, uncertainty is mainly including three things. If I'm doing some kind of a value exchange, I want to know who am I doing it with, right? The identity of the other party, of the other person, or the website. If it's a fake website or a good website, whatever. Second is if that value exchange has some kind of an asset being exchanged as well, right? So if I'm giving somebody some kind of a monetary value, then they're giving me some kind of another value in return. So that's why we do value exchange, right? So tracking of what's happening in the background with whatever I wanted to do the exchange for, and reneging. Now, reneging is basically if you have something that's not supposed to be. Let's say if you have a faulty toaster that you ordered online. Now that has to be returned, and your money has already gone to them. What do you do about it now? Now you got to go to the return policy and all that. So supply chain is the biggest industry that we could think about these days, right? It's one of the biggest industry that we could think about these days. So let's see if blockchain can solve all these problems. Okay, I have a few examples, and before I get into examples, I'd like to like introduce a secondary aspect of blockchain, which is called smart contracts. So up until now, what we learned was, okay, blockchain is fantastic. It has decentralization. It is very secure. Um, and it, to be able to manipulate it, it needs a lot of efforts. It's like it's helping us create that trust in other people by not trusting them. It's pretty funny. And by that, what I mean is, because if you are a miner, let's say, right, uh, you don't rely on someone else's transactional approval. You approve them by yourself by mining that transaction, right? So this this concept of not trusting each other and still coming together for having consensus is very fascinating, and that's why blockchain is widely adopted in this day and time. You guys must have already heard about Ethereum. I'm pretty sure if you so everybody who hears about blockchain, first thing that they hear about is Bitcoin, because that's how it was introduced, right? But everybody who looked into Bitcoin also would have heard about Ethereum. Now, the reason Ethereum is more talked about is because Ethereum is introducing smart contracts to this amazing technology that we have. Now, what are smart contracts? So I will explain in depth when we go into examples, but smart contracts are basically contracts that are executed on a blockchain with all the security levels and conditions and criteria that you want to define, right? So imagine having control over a value exchange based on the criterias, predefined criterias. So the value exchange will only happen if the predefined criterias are successfully fulfilled. Okay, so how about that? That right there is something that is a deadly combination, and will be replacing a lot of organizational exchanges that are happening, right? Um, so let me explain what smart contracts are and how supply chain would benefit from smart contracts. So everybody, I could have put Amazon up there. I could have put any Kijiji or any kind of online buying platform out there. So let's understand, when you're buying from any online platform, in this case eBay. First thing you do is you want to know who you are buying it from, the identity. Now these days, how do people do it? They go look. Is it a private buyer? Sorry, seller. Is it a private seller? Is it somebody who is just new, has a new profile, and you can't trust them? Is it somebody who has reviews? Is it somebody who has ratings? But all these reviews and ratings are forced and can be easily faked, right? So you still kind of have this untrustiness. You're still uncertain. You try to lower that uncertainty by validating yourself with reviews and ratings. That, okay, oh, this guy has 60,000 reviews on it, or it has 4.5 stars, and all that. You try to self-validate your decision by doing all that. But imagine the blockchain does this confirmation of identity for you before that person is allowed to make a transaction with you. Okay, so if let's say eBay was supposed to be a blockchain based online selling platform, so what they would do is any kind of person who is registered to be a seller will go through a security process that they will upload their identity, their whatever the criteria is the eBay decides to put out there. So the buyers from those sellers are protected based on identity. Now the second thing would be asset tracking. Now let's say, okay, the buyer is confirmed by our blockchain network and it's a good buyer. Let me send him the money. Now, how was blockchain introduced to us? It was introduced to us with a currency, a digital currency. So automatically the payment of an exchange of payment tokens is already there in blockchain, right? So that's a no-brainer. That's why I did not put any kind of payment information in here, because Bitcoin itself is a currency that was introduced to be peer-to-peer and have a fast transaction between person A and person B. So asset tracking, now once that payment has occurred, or whatever the terms are, maybe the person has to send the asset first, and it will be tracked throughout the journey, right? It will be tracked throughout the journey to the destination, and once it is once it is confirmed by the receiver that okay, it's good, then the smart contract will execute, and it will have paid the interested parties whatever, if it's a shipping company involved, they'll pay the shipping company its own share, it'll pay the seller its own share. So ethically, smart contracts are contracts that you define for a specific application, and those will be executed automatically on the blockchain when things are processed. So now reneging comes into the picture, which is, if the item is faulty. So I don't want to really go back into the returning thing and get out of the process and start a new process to return this item, right? So you could include that into your smart contracts, and the whole payment process will be held back until you confirm that yes, this product is good and I approve, and then it will go through. So the ease of doing whatever we already are doing is what making blockchain a very widespread phenomenon these days. So now, okay, eBay example was one example, but let's go more in supply chain. Let's go more in manufacturing. Like, Sandalwood is a manufacturing company. How manufacturing could benefit from blockchain, and how manufacturing supply chains could benefit from blockchain. So the example would be, let's say, any kind of company. Let's say, Tesla batteries, or any kind of production manufacturing facility. Well, imagine the raw materials that are being mined from the ground and are being recorded on the blockchain as the beginning of the cycle. Then they are sent to the production facility, and each process that is happening on to that raw material in that facility is being recorded by the blockchain. Okay, so up until now, this is already being done, not on a decentralized database, but on a centralized database. Okay. Every company has ERP systems. Every company has their own way of dealing with stuff. So the biggest relief here would be that if raw material is a different supplier, okay, and if production facility is a different supplier, they have different systems. They have different databases. They have different ERP systems, right? They have different factory information systems. So not necessarily a raw material provider who provides to 15 different companies will have the same system that these guys, that production guys, could talk to. Okay, so the bridge there is the biggest achievement in terms of blockchain. So it is decentralized, right? It is all cryptographically secure, so nobody will be able to see what information, which supplier is buying, which supplier is providing how much material to this buyer, right? So it's all cryptographically secure. But the bridge between two companies has been created now with the blockchain, and that same blockchain, the decentralized database, will be used by the processes down the line in the supply chain management cycle. Okay, so we are at the production level of our supply chain management cycle, and please ignore my liberty that I took to remove some processes from the supply chain management cycle, because I just wanted to focus on what implies to the explanation of blockchain regarding supply chain management cycles. Okay, so then now we move on to, let's say production is completely done. Now let's say we move on to quality check. Now the smart contract on the blockchain, I would say, will have some kind of a criteria that if Tesla is monitoring raw materials of their lead batteries, lead is being mined, sent to production, batteries have been made. Now those same batteries are being put to quality check. Now those batteries, each individual battery is being put through a quality check. Now imagine if that battery fails quality check, smart contracts will not pay the production guys for that battery check. So imagine the time saved on Teslas and when they receive the batteries to go through and quality check this, quality check that, and then create a separate basket for unfit batteries and all that, all that unnecessary process that they still do right now, or maybe they are smarter, they have a different way to do that, but they don't have to worry about, okay, quality department gave me a basket of batteries that are not going to be useful to us. We have to get a repayment on that from the production people, but that's not taken care of by the smart contract, because the smart contract will not pay the production guys unless the battery is good. So you only receive good batteries on your end when you're receiving it via shipping, right? So shipping is also the biggest part of supply chain management, and there comes the tracking of each individual aspect. And I also have an example, a real life example. I will give you guys a reference of this happening. But imagine the level of imagine the low level of uncertainty you have, and imagine the level of control and knowledge you have about your asset in your value exchange cycle that you are achieving using blockchain. So with shipping, you will have every aspect of your shipping stage, where it is and which is already being done, but it will be available to you through this decentralized blockchain database, right? And at the end, we have a happy customer, which is what everybody would like to see on a daily basis, correct? So this was all up until here. This was all concept, right? It was all conceptual. People were just imagining that this could be done, that could be done, and so on and so forth. But there's actually, because blockchain has been out for almost 13 years now, there's actually a company, and I picked this company just because it helps in environment, and it helps give the people the chance of lowering their uncertainty when they're dealing with food, right? So it is very interesting. Now you can go to this website and you can go and read about them. They're known as OpenSC, which is called opensupplychain.org. And what they did was, this is one of their projects, but I'm just going to talk about this project. What they did was they included blockchain part of the supply chain of fishing industry. Okay, so right from the source, correct? Right from the source, you can track. So imagine this: like even today, Apple and big companies like HP or IBM, computer manufacturers, have a hard time tracking down where was this particular chip made that they are getting in their phones, right? It's coming from China or here or there, whatever, but from the exact specific location. And me as a consumer of of a phone or a watch, I don't know where my chip on that computer or on my phone came from and who worked on it. I don't have the liberty to do that. Not even the manufacturers have the liberty to do that, right? So the level of uncertainty on even on the manufacturer's part is very high up until today. So what these guys, basically did was they just took the fishing industry as an example, and then they applied that to. So they are related to, not related to, but they work with the World Environmental Associations and WWF, actually, Worldwide Foundation. So they actually used, as sensors are getting cheaper and cheaper, more data could be collected very easily, and this should not be a surprise to all our data analytics students. So as sensors are getting very, very cheap, people are implementing sensors everywhere in any kind of industry, right? So what these guys did was they took sensors and they put it in boats, fishing boats, and they read the depth of the ocean where these boats were fishing from. They read the time of their fishing. So when was the fish caught, on what depth the fish was caught, because the net is deployed on a certain depth. and they bring that fish on board, and every fish was tagged by an RFID tag, a unique tag, and that tag is basically on that fish up until that fish comes to the shore and is being processed. Now, when the fish is being processed, and when it goes through each stage, that RFID tag is scanned, right? And that RFID tag is kind of showing the journey of the fish from the time it was caught, right? Because it's meat, right? You don't want meat which was caught 2 years ago in your fridge. So from the time it was caught and from the process as it went, you can see each level of process that the fish went through. And once the fish is ready to be made into a packaged product, or a fillet, so you cannot send an actual RFID tag with people to their homes, right, with the package. So at the very end of the packaging, that RFID is taken out and is replaced with a QR code on the package of the fish. Now that QR code is then scanned by the shipping company to be able to ship it to your nearest grocery store. So you as a consumer, when you go and when you buy the fish, you can know that this fish was basically caught at this time, at this location, which is legal to do. A lot of fishing is illegal, right? There's legal zones, illegal zones, and timings. Certain fish are only supposed to be caught during certain time of the year, and all those things. Because if I'm paying for something, right? If I have the control over paying for an object that I want to go buy, why don't I get the same control in return to be able to know what I'm getting and where it is coming from, right? So the discontinuation of trust was not there before. Well, was there before. Now we have that trust factor becoming higher and higher because of blockchain, and we can see everything is open, everything is decentralized. You can revert back to whatever it is. So another quick example that before I like to finish my guest lecture, another thing that I would like to add on to this lecture is that don't when you start imagining the use of blockchain, do not limit yourself to just financial stuff. Do not limit yourself to exchange of money from country A to country B faster. Um, imagine your daily routines, your daily processes, which have value exchange involved, right? Let's say you go drive down the road and get a cup of coffee. You're having a value exchange there. You're having meetings with your fellow colleagues. So you're giving your intellectual property to them, and value exchange is happening there. So use your creativity. Imagine the applications of blockchain in your day-to-day life, and hopefully you'll be able to incorporate this in your supply chain analytics journey. With that, I would like to open it up for questions, and I will stop recording this this lecture. That's all I had, guys.
Did you stop recording?
Yeah, I'm just doing that right now. Stop.